Generative AI model orchestration involves managing several generative AI models concurrently to accomplish complex tasks. The orchestration improves efficiency and accuracy by leveraging the unique strengths of each model. For example, tasks involving multimodal data could employ different AI models for text generation, image creation, code generation, and natural language processing, ensuring optimal results. Orchestration in Azure not only streamlines model management, but also simplifies integrating various outputs into coherent and valuable results for different business requirements. Enhance performance. Leverage strengths of multiple models for superior outcomes. Flexibility. Easily integrate diverse models catering to specific tasks. Scalability. Adjust model usage based on resource demand and computational needs. Cost efficiency. Optimize usage to minimize unnecessary resource expenditure. Innovation. Quickly experiment with novel model combinations to meet emerging needs. Reliability. Maintain service continuity through intelligent fallbacks and redundant models. In orchestration scenarios, common generative AI models include language models, LLM GPT-3, GPT-4 for text and code generation. Image generation models, DALL-E, Stable Diffusion for visual tasks. Multimodal models, GPT-4 Vision, integrating text and visual input. Domain-specific models, specialized models fine-tuned on data relevant to particular businesses or industries. Utilizing appropriate model combinations facilitates richer, more accurate outcomes tailored to diverse user needs and application scenarios. Azure provides several tools to orchestrate multiple generative AI models efficiently. Azure OpenAI Service. Deploy and manage large language models. Azure AI Foundry. Integrates AI models, enabling project-specific orchestration. Azure Machine Learning. Create complex pipelines and orchestrations tailored to AI workflows. Logic Apps and Azure Functions. Automate model invocation and process orchestration. Leveraging these Azure services streamlines complex orchestration tasks, enabling easier deployment and maintenance of sophisticated AI-driven solutions. Effective orchestration architectures typically include sequential architectures, models executed in a predefined order, each feeding data forward. Parallel architectures, models run simultaneously to expedite results and improve responsiveness. Conditional architectures, model execution paths determined by dynamic conditions evaluated at runtime. Hybrid architectures, combination of sequential and parallel layers to handle complex requirements. Understanding these architectures helps select suitable methods for your specific AI application scenarios and optimize overall flexibility and performance. Sequential orchestration executes models in a structured, linear manner. Consider a chatbot application. User query handled first by a language model to interpret the request. Filtered input passed to a specialized model, e.g. code generation. Secondary model output passed to another AI model for translation or summarization. This sequential structure ensures each step's outcome correctly feeds into subsequent actions, maintaining high output accuracy and relevance. Parallel orchestration runs multiple models simultaneously to enhance responsiveness and productivity. An example, user submits multimodal input, text and image. Image processed simultaneously by a vision model, while text is interpreted by a language model. Results combined in a final integration step to provide cohesive user output. This arrangement markedly reduces processing time and improves the system's ability to manage complex, resource-intensive tasks concurrently. Conditional orchestration dynamically determines model workflows based on data or context. For instance, a customer support automated service applies sentiment analysis initially. Positive inputs routed directly to information retrieval models. Negative or critical inputs trigger specialized support or escalation models to address concerns effectively. Conditional orchestration enhances system efficiency, adapts responses according to context, and optimizes computational resources, consequently improving user satisfaction. Hybrid orchestration merges sequential, parallel, and conditional execution for maximum flexibility. Practical applications include complex data analytics pipelines that invoke text, image, and predictive models processed simultaneously and conditionally. Healthcare diagnostics systems utilizing sequential diagnostics models, then branching conditionally into specialized imaging or language models. Hybrid strategies significantly boost performance while remaining deeply adaptable to data diversity and complexity. Orchestration complexity necessitates diligent management strategies. Maintain clear documentation detailing orchestration logic and model interactions. Employ consistent naming conventions and standardized interfaces. Utilize Azure AI services to provide monitoring, alerting, and automated continuous integration and continuous deployment (CI/CD) mechanisms. Regularly perform endpoint testing and validation of each model and step within the orchestration, ensuring robust, maintainable solutions. Monitoring ensures orchestrated systems remain operative, efficient, and accurate. Azure AI Service dashboards monitor latency, performance, and resources. Tracking systems record model failures and performance degradations. Real-time diagnostic analytics identify bottlenecks or resource issues. User feedback and tracing support model improvement and orchestration adjustments. Empowering systematic monitoring enables proactive management, rapid issue resolution, and continuous model refinement. Clearly define data handling between orchestrated steps. Optimize resource allocation dynamically to reduce costs and maximize efficiency. Incorporate fallbacks and model redundancy to maintain service reliability. Regularly review and update your models and orchestrations based on new data or capabilities. Ensure security and compliance throughout the orchestration process, especially when handling sensitive or regulated data. Security considerations in orchestrated AI solutions include enforcing authentication and authorization policies strictly across all model endpoints and orchestration logic. Monitoring and setting alerts for unexpected or anomalous behaviors, reducing cybersecurity risks. Implementing data anonymization practices in sensitive contexts. Compliance with regional data governance laws, GDPR, HIPAA, through Azure's built-in compliance tools and certifications. Adhering to stringent security and compliance practices protects data, secures trust, and aligns solutions with global standards.